The James Webb Space Telescope, our most powerful eye in the sky, has been studying Proxima b, a planet that's captured everyone's imagination. For years we only had limited information, but now, thanks to JWST's infrared capabilities, we're finally getting a much clearer look. And the results are a mix of excitement and concern. Proxima b was first discovered back in 2013, orbiting the red dwarf star Proxima Centauri. It's incredibly close to its star, just 7.3 million kilometers away, which is less than 5% of the distance between Earth and the Sun. Because of that, it completes a full orbit in only 11.2 Earth days. But that closeness comes with big problems. Red dwarfs like Proxima Centauri are known for being volatile, unleashing intense solar flares that can seriously damage any nearby planets. Now, JWST is showing us a far more detailed picture of Proxima b. We've learned it's about 30% bigger than Earth, meaning it has stronger gravity. But one of the most fascinating and worrying discoveries is that Proxima b might be tidally locked. That means one side of the planet always faces the star, locked in endless daylight, while the other side remains in permanent darkness. Imagine standing on a world where the sun never sets, while on the opposite side, it's an endless frozen night. This creates a huge problem for life. The day side would be bombarded by dangerous radiation, making it incredibly hot and hostile. The night side would be freezing cold, far colder than any conditions we experience on Earth. Could anything survive such extremes? It seems unlikely, but then again nature always finds surprising ways to adapt. One major concern is the intense radiation Proxima b gets from its star. Proxima Centauri is far more active than scientists initially believed. In 2021, it released a massive flare, over 100 times stronger than anything our own sun has ever produced. That kind of blast could easily strip away any atmosphere a planet might have. Some experts believe Proxima b's close orbit and constant flaring mean it probably lost most, if not all, of its atmosphere long ago. Others argue that life might still cling on in some hidden, protected areas. There's still a glimmer of hope that Proxima b retains a thin atmosphere, perhaps made up of heavier gases like carbon dioxide or nitrogen. Such an atmosphere could offer some protection from deadly radiation. Thanks to JWST, we're starting to see that Proxima b has a rocky surface like Earth, but it's anything but ordinary. The day side is likely a scorched wasteland, while the dark side might be a frozen desert. However, there's an interesting region scientists are calling the twilight zone, the narrow strip between the eternal day and the endless night. Here, temperatures might be just right for liquid water to exist. Liquid water is the key to life as we know it. If there are even small puddles or underground water reservoirs in the twilight zone, there's a real chance that some form of life could be hiding there. Some researchers even suggest that Proxima b could have underground oceans, similar to what we see on icy moons like Europa and Enceladus in our own solar system. These hidden oceans could be warmed by internal heat or energy from the star itself, providing a protected environment for life to evolve. Still, life on Proxima b would face brutal challenges. Besides the intense radiation, the planet's survival might depend on its magnetic field. Earth's magnetic field protects us from solar wind and harmful cosmic radiation. If Proxima b has a similar magnetic field, it could shield at least part of its surface. Some scientists think the interaction between Proxima Centauri's magnetic field and Proxima b's core might have created such a protective shield, but there's no confirmation yet. Even if it exists, the sheer power of the star's flares might still overwhelm the planet's defenses, dramatically affecting its climate and environment. This leads to even bigger questions. Does Proxima b really have a magnetic field? How strong is it? Can it actually protect the atmosphere and, more importantly, the possibility of life? If life does exist on Proxima b, it would likely be very different from anything we know. It might resemble the extremophiles on Earth, tiny organisms that thrive in extreme heat, cold, radiation, and toxic environments. Even though the idea of Proxima b being a second Earth is exciting, reality paints a harsher picture. JWST's observations are helping us understand just how tough survival would be there. The intense ultraviolet and X-ray radiation could destroy any surface life, strip away water, and bake the rocks. Meanwhile, the freezing temperatures on the dark side wouldn't offer a safe refuge either. Still, humanity isn't giving up on reaching Proxima Centauri. The Breakthrough Starshot project, backed by big names like Stephen Hawking, plans to send thousands of tiny laser-powered spacecraft toward the star system. These microprobes, each no bigger than a postage stamp, would travel at 20% the speed of light, reaching Proxima Centauri in just a few decades. They could send back priceless data about Proxima b and its neighbors, perhaps answering once and for all if life can survive there. Whether Proxima b is a promising second home or just a cosmic warning, it's already helping shape the future of space exploration. And we're only just beginning to uncover its secrets. The discoveries about Proxima b have left scientists both excited and concerned. Thanks to the James Webb Space Telescope (JWST), we now have clearer insights into this nearby exoplanet, only 4.2 light-years away. Proxima b orbits its star, Proxima Centauri, at a very close distance of just 7.3 million kilometers, less than 5% of the distance between Earth and the Sun. It completes a full orbit in just 11 Earth days. However, Proxima Centauri is a red dwarf star very different from our Sun, and it is known for being extremely volatile. Red dwarfs like it frequently emit powerful solar flares, making life on any nearby planet very challenging. JWST has provided the clearest images yet of Proxima b, revealing that the planet is about 30% larger than Earth and has stronger gravity. However, it is likely tidally locked, meaning one side always faces the star while the other remains in permanent darkness. This setup creates a world where one hemisphere is scorching hot and the other is freezing cold, posing a huge challenge for life as we know it. Proxima Centauri's high activity makes Proxima b's situation even worse. The star's strong magnetic fields result in intense flares, sometimes 100 times stronger than those from our Sun. A notable flare in April 2021 could have been strong enough to strip away any existing atmosphere on Proxima b. Scientists are divided on whether life could exist there. Some argue the harsh conditions are too extreme, while others suggest that life might find a way to adapt, just as extremophiles on Earth survive in the harshest environments. As JWST continues to investigate, we are slowly uncovering the planet's mysteries. Despite the difficult conditions, Proxima b remains a crucial target for the search for alien life. One of the major discoveries concerns Proxima b's atmosphere, or rather, the question of whether it even has one. The intense radiation and solar wind from Proxima Centauri could easily erode an atmosphere over time, leaving behind a barren, airless world. Yet there is some hope. Some scientists think Proxima b could still have a thin atmosphere made up of gases like carbon dioxide or nitrogen, which might offer some protection against the star's relentless radiation. JWST's data suggests that the planet's surface is rocky, like Earth's, with the star-facing side scorched into a desert while the dark side is frozen solid. However, there might be a narrow zone between these two extremes, the twilight zone, where temperatures are more moderate, possibly allowing liquid water to exist. Water is crucial for life, and the twilight zone offers the best chance for its presence. There's also speculation that underground oceans might exist beneath Proxima b's surface, similar to what we see on Europa and Enceladus in our solar system. If true, these hidden oceans, heated by the planet's core, could serve as safe havens for life, shielded from the hostile surface environment. The existence of such underground oceans would significantly boost the chances of finding life, even if the surface is deadly. Another important question involves Proxima b's magnetic field. If the planet has a strong magnetic field of its own, it could protect any remaining atmosphere from being stripped away by stellar flares. However, if its magnetic field is weak or damaged by frequent solar storms, the surface conditions would be even harsher. Scientists are eager to find out whether Proxima b has a protective magnetic field and how strong it might be. These details could tell us a lot about the planet's ability to host life. Despite all the excitement, it's important to remember that Proxima b is not a friendly place. It faces continuous exposure to powerful radiation, and the flares from Proxima Centauri are strong enough to vaporize any surface water and strip away any fragile atmosphere. The landscape itself is shaped by the planet's extreme heat and cold, making it an unstable and volatile environment. Even so, these challenges haven't stopped scientists from dreaming big. Initiatives like Breakthrough Starshot plan to send tiny spacecraft traveling at 20% the speed of light to the Alpha Centauri system, including Proxima Centauri, to gather close-up data. These missions could transform our understanding of Proxima b and its potential to support life. Proxima b might not be the safe, Earth-like haven we once hoped for, but it still plays a critical role in humanity's search for extraterrestrial life. Its extreme conditions force us to rethink what a habitable world might look like. Life elsewhere might not resemble anything we see on Earth. Instead of lush forests or blue oceans, life could survive hidden beneath rocky surfaces or in deep, dark oceans protected from harsh radiation. Studying Proxima b could give us a whole new perspective on where and how life might exist in the universe. Ultimately, Proxima b symbolizes the spirit of exploration. Even if it turns out to be a hostile world, The lessons we learn will guide future searches for life beyond our solar system. It shows us that life may be far more adaptable than we ever imagined, or it could remind us just how rare and precious Earth truly is. Either way, our journey toward answering one of humanity's oldest questions, are we alone? Is just beginning, and Proxima b is leading the way.